Speaking of wrong, we have a new theory of aging. We used to think that antioxidants were the cure to aging. And if you go to the supermarket, you'll still get a lot of that bull. It's not true. Antioxidants have been really unsuccessful at lengthening the lifespan of anything, even a worm. It doesn't work that well. The reason is that there's much more going on than just free radical damage. What we need to do is to tap into our body's natural defenses against aging. And the group of genes that I work on are called the Sirtuins, and they respond to all of the things that we do, the adversity, the exercise, the fasting. And this group of genes and these proteins that the genes make sense the environment, and when times are thought to be tough and could threaten us, they fight harder to keep our body safe, protected, and ultimately healthier and longer lived, even late in life. And what they're doing, these Sirtuins, is controlling this structure here. They're doing a lot of things, I should say, but the main thing that I believe they're doing to make us live longer is controlling what we call the epigenome. If you haven't heard of the epigenome, think of it like this. We have DNA. The epigenome is not digital. It's mostly analog. And anyone who's old enough to have had an analog device, whether it's a tape recorder or a record player or record, these things get disrupted, they get scratched. It's very bad, very poor at copying information. And that's true for the epigenome as well. Copying epigenetic information doesn't work that well. What is the epigenome? It's the structures that wrap up the DNA and say that this gene A should be on in a brain cell, but in a liver cell should be off. And this gene B should be off in a skin cell, but should be on in a kidney. But here's the analogy, that the DNA is the digital information on a compact disc. Those of us who are old enough know what that is. For the youngsters, this is what we used to store 20 songs on. It was great technology. That's your genome, the digital information. The epigenome is the reader, and it can read different songs depending on different parts of the body and different cell types. But what I believe is causing aging is the skipping of those songs, skipping of the reader. And what makes songs skip? Scratches. So aging is essentially scratches on a compact disc that makes the music skip. And eventually cells, by reading the wrong genes, skipping the wrong genes, lose their ability to fight against disease. They lose their function. We get dementia, we get heart disease, we get cancer, we get frailty. That is aging. So with this new theory of what I call the information theory of aging, we can perhaps test this by testing if epigenetic changes cause aging. And if that's true, is it possible to reset these structures back to being young? Is there a backup copy of the epigenome? In other words, can you polish that CD and get back the original music of our youth? Number of times the Earth's gone around the sun, are you kidding me? That's not your real age. What your real age is this, changes to the epigenome that determine how old you really are.